Hello everyone, my summer internship was at Ecole Polytechnique under the supervision of Dr. Alistair Rowe and his graduate student Indira, along with fellow iREU intern Jill. Our lab aimed to measure nanoradian Faraday rotations in semiconductors. Faraday rotations are rotations in the polarization angle of light as it propagates through a material placed in a magnetic field. There are two primary optical setups we can use to measure these rotations, a Sagnac interferometer and an optical bridge. The Sagnac is a common path interferometer in which two beams travel in opposite directions around a loop and interfere with each other, adding constructively or destructively depending on their respective phases. The optical bridge works by dividing the beam into two based on the polarization and measuring the difference in the signals entering the detectors. We measured the noise characteristics of both setups at low intensities. There are two kinds of noise in the system, source and shot. Source noise is the noise due to defects in the setup, laser, and so forth. It is linearly proportional to the intensity of the laser beam. Shot noise is intrinsic to the system and caused by the particle nature of photons. Hence, it is desirable to be in this range. It is proportional to the square root of the intensity. We measured this trend at various laser power ranges on the two setups and found that the optical bridge yields shot noise limited measurements for higher intensities than the Sagnac. The advantage of these higher intensities is a larger signal-to-noise ratio. Therefore, the optical bridge demonstrates a superior performance to the Sagnac. However, the Sagnac is still useful for other reasons. Different configurations of a Sagnac allow one to isolate rotations in the polarization of light due to different magneto-optical effects. Thus, a Sagnac can be configured to measure only Faraday rotations or only rotations due to birefringence. The next step is to construct and test the various Sagnac configurations to compare them against the theory. Thank you for watching.